today. Um, Over the next 30 minutes or so, we're going to talk about some things that you can do to prevent your next outage. Our speaker today is Continuity Software's CTO, Doron Pinhas. Doron is not only a renowned expert in infrastructure resiliency, but he spends most of his days talking to infrastructure executives at many of the world's leading IT organizations. So we are very fortunate that he is here to share his vast experience and expertise with us in this session. At the end of Doron's presentation, we hope to have time for some questions from the audience. So feel free to post questions at any time during the presentation using the panel on the right side of your screen. And with that, without any further ado, I will turn it over to Doron.
For today's agenda, we'll talk about the state of IT resiliency in 2016, which has been a problematic year for many organizations, and try to explore what's the reason behind some of the challenges. We'll talk about things that you can do with a particular focus on our own technology, which is called Availability Guard, and we'll do our best to accommodate as many questions and answers. And with that, let's just spend 30 seconds about Continuity Software. We have been around since 2005. We partner with the world's leading IT infrastructure providers. That covers storage, servers, compute, networking, applications, and whatnot. And we help enterprises across the globe to prevent the risk of downtime and data loss. So this is what a minor outage may look like, right? Now, when they grow larger, they can take a more ominous shape. We will review some of the outages of this year, but definitely the Delta incident that many of you may have witnessed is still looming. Now, IT outages and IT service disruptions are actually very common. In many cases, they don't take an all-encompassing shape in the form of a complete meltdown like Delta has experienced. When you take a zoom into the daily life of IT operational teams, you'll notice that about 70% of their time is spent in firefighting, staying over business hours and over weekends to save the day. When we drill down into any one of those disruptive events, we'll notice the following. A, they are typically unexpected. From the perspective of IT management, end users, reporters, it always takes too long to resolve than required, even if we can recover within an hour or so, let alone days, which means that everyone's under pressure, which means that we'll see a lot of finger pointing at times. And it also means that there is not enough opportunity to slow down and figure out what is the real root cause. For that reason, many of the outages are recurring in nature. So you'll see IT teams struggling with the same problems all over again. Now, the state of affair is not changing to the better over the years. There is a series of interesting articles we publish, and you can access them on our site, that review the state of the IT industry as a whole as it relates to service availability in various metrics. This is just one data point, which basically demonstrates that in the last 2 years, the overall stability of IT infrastructure has not improved. In fact, it has deteriorated in all major metrics, despite a huge effort in automation, orchestration, virtualization, active-active technologies that are supposed to make all that an issue of the past. So let's just zoom into some of the events in just recent months. I've mentioned Delta Airlines earlier. They had an outage that lasted about 3 days. The reported damages were in the order of magnitude of $150 million. Now, the reason given by Delta was pretty much consistently that they had an issue in one of their power switches. And while I'm definitely not questioning the authenticity of the claim, I'm absolutely certain that it started with a power failure. I just wonder if that can explain a meltdown of the entire IT infrastructure, which was designed for full redundancy. So they had a very well orchestrated plan, it just did not work. So that's probably more of the reason that the disaster recovery and active infrastructure was not really ready, and we'll drill down into that concept. So we had another issue a little earlier this year with WorldPay, where north of 1 million transactions have been affected for a very long time, so a huge amount of money involved. Numbers were not disclosed, and the advertised reason was server update. And again, I'm just questioning whether an individualized incident in a single component can affect an entire IT infrastructure. Earlier than that, we had the Southwest Airlines. Generally speaking, the airline industry seemed to be a little bit more sensitive than others in the last couple of quarters. I don't have any good reason why. A lot of flights canceled, and the reason was a network, advertised at least, was a network router failure. And hopefully you start seeing the pattern here. Deutsche Bank had an issue where they couldn't swap a huge amount of valuable transactional data for a long time. They did not advertise a reason. And just as we were finalizing this presentation, we came across two incidents just from the recent days. Bank of New York Mellon had a significant IT stability issues just at the end of last week, and yesterday practically, the Australian Tax Authority lost, sits tight, 1 petabyte of data, which took them a lot of time to bypass. And obviously, they haven't recovered everything yet. So why does it keep on happening? And definitely you can see the theme here. It's not for lack of trying or because people spare or save money, time, funds, and even passion in building a resilient infrastructure. In fact, all of the enterprises mentioned do invest in resiliency. And that actually means that they need to bring together a lot of technologies. It's not a cookie cutter. So we are talking about multiple data centers with data replication and mirroring. In many cases, it's active-active. We have a lot of resiliency in every layer of IT, networking, storage and storage networking, compute, clustering, virtualization. All of them are designed for high availability. But because we have so many technologies from so many vendors, we face the following challenge. So the only constant in IT, perhaps, is change. We have to apply daily patches. We have to upgrade our core applications. We have to retire old gear. We have to fire up new virtual machines, add more capacity. And that's happening day in and day out by multiple teams. In many cases, vendors will also step in to assist. Communication is not always perfect, to say the least. And to top the complexity, the technology is actually changing quite rapidly. Just the last week, I have been reviewing the evolution of storage I/O control, SIOC, in VMware infrastructure in versions 5.5, 6, and 6.1. Tunables and tunable best practice have just changed 100 degrees all over between each one of those versions. So that can get users confused. You may adapt and create well-structured best practices and standards, but as you deploy them, it's not absolutely certain you're doing the right thing anymore. So when you couple all of those together, you get the following situation. Every now and a while, some of those routine updates can erode the stability and reliability of IT. They may introduce single points of failure. They may slip in between the cracks. When you take a look at the risk landscape, as it were, you can see that a lot of changes are piling up pretty quickly. Each change introduces a slight risk, and the risk can only grow. Right? At certain points in time, we actually know it's minimal. For example, when we onboard a new system. Typically, before it's live, we have some time to perform acceptance test planning that we can plan ahead. We can spend days or even weeks making sure it's perfect. In some cases, or a lot of enterprises strive to do yearly audits or tests or tabletop tests. While not perfectly comprehensive, at least they allow us to take a wider approach and reduce the risk. But in between, the risk level remains constantly unknown, and I would argue that most IT executives actually suspect that pretty quickly it passes a threshold beyond which IT is no longer resilient. And just to illustrate that point, and you know, think for yourself, what will happen if tomorrow a storm is coming in or an unplanned serious outage will happen? How certain are you that all of your systems will continue performing gracefully and whatever needs to be shifted to a different location will function? So that's not trivial. This picture, by the way, so I'm told, was taken during Hurricane Sandy, which is one of the more significant wide-scale events of recent years. And the point I want to make here is that 48 hours before the storm hit the shore, this was what the forecast looking like. Basically, it was not perfectly clear what could be the impact. Some even argued that the storm may have minimal effect or may not even reach the shore, whereas others argue that the risk is actually significant. But pretty much every IT exec in the Northeast had a 48 advance notice to prepare, potentially shift the workloads to a safer location and make any precaution necessary. And then guess what? While we have not run a scientific research, we have talked with dozens of customers. In my estimate, about 80% consciously has chosen not to flip workloads simply because they were practically certain that the failover may actually disrupt the business more significantly than being hit by a storm. And then guess what? 2 days later, the storm did hit the shore with quite a significant impact, and a lot of those companies could not recover successfully. So if that's the reality, how can you prevent your next outage, and what can be done? So generally speaking, we want to transform our risk landscape from an unknown quantity that gradually grows to the point where we no longer trust our ability to recover to something like what we see on the bottom over here. We want to be able to assess the quality and readiness of our infrastructure after every change and actually isolate and identify changes that can derail the stability. So measurement is key to improvement. How can we do that? Now, at Continuity, we have been perfecting methods, tools, and technologies to solve that particular problem for the last decade or so. And pardon me for just 1 second. The winter stall is here. So what I'm going to present in the following slides are the best practices we have learned. I'll focus mostly on our own technology, which is called Availability Guard. But please bear in mind that a lot of the concepts we're going to cover can be achieved by other means. So basically, Availability Guards allows enterprises to build 4 key features: visibility, knowledge-driven design and decision-making, managed processes, and resiliency control. Let's drill down into each one of those elements. So the first one is visibility. It can be achieved in many ways. The way Availability Guard performs it is by performing cross-domain scan of the infrastructure. The product utilizes existing management protocols that most IT components provide today, whether these are storage, blade servers, networks, SAN fabric switches, virtual consoles. All of them has well-structured APIs that allows us to gather data in read-only mode in a non-intrusive way, using no agents whatsoever. We also have added over the years the ability to gather data from multiple other sources, such as CMDBs. So all of those different data points are automatically connected to create a documentation of your infrastructure. And basically, this is the support matrix we covered today. As you can see, it goes far and deep. It's actually a very, very concise summary of a 27-page long document. We support all the major distributed operating systems, storage platforms, replication engines, whether storage-based, host-based, database-based, hypervisor-based, clustering tools, app servers, databases, and so on. And when we correlate the data from all of those discrete components, Availability Guard can automatically connect the dots and create the diagrams I'm showing right now totally automatically. There's absolutely no human intervention now. These get updated on a regular basis. Having up-to-date documentation of the different elements of your infrastructure can be key both for planning, decision-making, and recovery. And we'll see some of the use cases. What if we can compare our pre-production environment to production when things don't work as we advertise? What if we can gather the data about our production configuration after a failure when recovery doesn't work as we expect? So these are things you can get out of the box. But visualization and documentation is just one bit of the puzzle. Perhaps one of the key elements of building a successful practice is introducing knowledge. The way Availability Guard provides that capability is by introducing the concept of automated risk detection. We have a patented technology that can look for known problems and search for best practice or vendor best practice deviations in an infrastructure. Today, the knowledge base contains north of 7,000, the actual number here is no longer current, north of 7,000 predefined checks that are based both on the vendor recommendations and also on the knowledge of the community. We have a very wide community with which we meet regularly. In many cases, they try the bleeding edge technologies, and in more often than you'd expect, they will detect potential problems that the vendors did not anticipate. Especially as we deploy new technologies, there is always the risk of the unknown. We are on the junction where we can gather all of that intel, so we add it to the knowledge base. And when any new customer deploys it or try it for a one-time scan, you can see a lot of insight and identify opportunities to prevent potential issues you haven't even detected, but others have to their cost. So whenever a risk is detected, it's correlated not just with the technical object, but also with the business service. So just to illustrate some of those concepts, when the tool runs, it can provide varied views into detected issues. It's backed by a built-in ticketing engine that can integrate to other tools. And you can zoom into risks, see the individual occurrences within, let's say, last night or last week. What kind of issues occurred? What is the risk and priority to fix? And there is a lot of detail carried for each one of those. It's not just a notification that something may not work. It's actually a complete capture of the problem. There is a discussion about the impact of each issue. There are step-by-step instructions on how to resolve it. There is contextual info about the history of each and every event. When did it happen? How long is it opened? Did it get closed? Did it get reopened? Which will then allow to hash and mine the data. We'll see that in just one bit. And as you further zoom in, you can get all the power of automated documentation. You can get visual representation of issues that were detected. In this case, we can see a scenario where mission-critical data is not fully managed on the right storage tier. So when we try to shift the workload, we will lose large amounts of data. So basically, detecting risk is a foundation of a process. So risk detection itself is great, but in order to make it actionable, we have created a mechanism that allows you to actually manage the risk posture and make it actionable. So the way it works is the following. There are a lot of APIs and predefined interfaces with existing IT tools. The philosophy is that you don't want to change your existing process, but rather build up on top of them. So you can automatically assign detected issues by severity, role, and function to the right individuals within the enterprises. And furthermore, Availability Guard tracks the actual resolution status. You don't have to confirm things are solved. The tool will just rerun the quality check. If a problem is solved, it will actually let you know and potentially close the incident within your change controls. And if it hasn't, it will insist that the problem is still there. So setting up those connectors is actually extremely straightforward. There is a predefined library of connectors to all leading tools like ServiceNow, Service Manager, Patrol, CMDB engines, and others. Last but not least is the ability to allow you complete oversight, both from the perspective of a snapshot of the infrastructure. so you can decide what to do if a storm is hitting tomorrow. Just take a look at your risk posture right now, drill in and see if you're ready, and if not, what needs to be done. But also over time, so you can assess and measure the service availability metrics, how they stack against your plan, what can be done to improve, to constantly improve. So this is basically what the dashboard looks like, and you can actually consume all of that data from SharePoint or other portals. If we take a quick view at the top row on the right, this is a business service. It may have been perfectly green yesterday, and last night we have perhaps created an update by several teams. You don't have to wait for the morning to come to figure out if you've missed anything. You just run a scan, and in this case we see that the risks to the data have been detected, as well as risk to availability. Some of the changes are not optimal, and finally, once the changes were made, we no longer meet our service level objectives, which is another automated feature of Availability Guard. You can basically decide or define what are your requirements for RTOs and RPOs and capacities and data retention for, let's say, applications you design to be cyber resilient. You can define a profile of protection for a particular app, let Availability Guard know, and it will track compliance on a regular basis. So this is by way of a snapshot. If we want to fail over our ERP system because the storm is coming, we can drill down into each one of those components. But because we do have 48 hours, we can have our teams check them, vet them, fix them, have Availability Guard validate that everything is ready, and then we know with much higher certainty that we can actually fail over. So that's for one-time views, but obviously you can take a wider view into consideration and review operations. What types of exposure do we have over time? What types of risks? Are we improving? What's the average time to fix by team, by vendor? What's my risk posture over time? What is my risk score? Is it improving? You can set goals and track them. And finally, there are other controls. That the idea here is not to run through a full tutorial of the tool, but you can also compare server configurations and application configurations against your own standard builds, just to see that you have component compliance or server compliance. You can compare servers to see if you have the same patch level or updates, or compare them to a golden copy. And you can also fire up automated alerts if you fail to meet those self-defined standards. So setting up a process that includes that level of automation has a lot of benefits. The fact that you can actually measure and track readiness on a daily basis, isolate the issues and fix them before they impact recoverability, has a far-reaching effect on IT operations. First of all, there is dramatic improvement in IT agility, which is a factor we have not anticipated ourselves. We start getting reports from customers, especially as they were modernizing data centers, that once they started using Availability Guard, they discovered processes run much faster because the automated quality control the tool provides while you study the new technologies in your lab and then roll them into production, and the maturity it fosters dramatically reduces the time it takes to confidently perform changes by a tremendous factor, from weeks per change to days. Of course, it provides automated proof of compliance, especially for those of you that are regulated and are required to provide more and more stringent resiliency proof, and more frequently. The removal of that burden from a manual process to an automated one is tremendous. There is significant reduction in a lot of IT operation metrics, like far less downtime, far less firefighting, because an ounce of prevention is worth a pound of cure. When you can fix issues while they're fresh, the implications are far less wide-reaching. And there is tremendous reduction in the amount of effort or manual effort associated with testing and auditing. All of those factors boil down to the fact that your IT infrastructure will be more resilient. Daily tests, whether that's done with Availability Guard or any other means, daily validation and frequent checkpoints foster proactivity, and proactivity increase success. which means that business executives will have far more confidence in the money they spend in IT, which generally speaking improves not only resilience but also the pace of change and so on. So with that, I want to, and just potentially before going to the Q&A session, I want to point your attention to the last two data points. Of course, there is much more information on our website on all the items I've just mentioned, on our technology, on our surveys, and on the technology itself. There is also the option to utilize Availability Guard as a tool for a one-time assessment of your infrastructure. So if there are pieces of the infrastructure you're concerned about that are not performing well or were newly built and you're not absolutely certain they're fully resilient, you can take us on the offer to run a quick assessment. This is an agentless technologies, and there are options that range between a 1-hour assessment to a couple of days, and the reports are spectacular. So enough product selling. With that, I'll turn the stage into your question. I hope this was informative. Eran, if you can chime in, hopefully you have gathered the audience questions
Sure,
throughout
yeah.
the session.
Yes, thank you, Doron. This was very informative, very insightful. And we do have a number of questions here. I'm not sure we'll get to all of them. If we don't get to your question, we will get back to you offline via email following this webinar. But let's try to answer at least a few of them here. So, Doron, one question relates to your mention of the knowledge base. The question is, where is this knowledge coming from and how often is it updated?
Got it. Okay, so in a sense, I think the question itself actually suggests the answer. It is updated regularly. It's a little bit like in antivirus technologies, if you may. We do regularly update the knowledge base. The knowledge comes from two main sources. We have extremely close ties with all the leading vendors. You've seen the support matrix. We are gold partners, design partners, technology partners of all of them. We have early access to release notes. We have access to engineering teams, and we review, obviously, the literature cover to cover. So our mission in life is to capture the vendor best practices on a regular basis. Because we have been doing it for so much time, we became quite adept. So that's one source. But the other is our user community. We have regular interaction with our customers. With some of them, we actually manage the tool for them as a managed service, so we gain tremendous insight into real-life challenges customers face, and the majority of the new issues are discovered where customers deploy the bleeding-edge technologies. All right, so in the last 2 years, a lot of our customers started utilizing active technologies like VCLEX, G1000, GAD from Hitachi, SVCs, active storage. A lot of new discoveries were made around the correct ways to set up the infrastructure that the vendors themselves did not anticipate. We add those on a regular basis, so all of our customers can share the experience of the customers. For the frequency itself, on average, it's not as frequent as antivirus, but on average, every 2 weeks, there is new content. So there's absolutely no rush for you to update it every 2 weeks. But the update process itself takes a couple of clicks, and we can do it for you. So hopefully that covered the question. What else do we have, Eran?
Sure, thank you. So one other question, can I automate my own checks? We have created a set of several dozens of our own daily checks, but your platform looks much more comprehensive, but can we incorporate our own? I guess that's what the question is here.
Got it. Of course. So yes, I'm glad to say the answer is positive. In fact, we've actually introduced that feature, I think, around 2 years ago for exactly the reason specified. A lot of customers appreciate the fact that the tool provides out-of-the-box vendor or an industry best practices, but each and every enterprise may have their own unique settings. If you've already, and to the person who posted the question, if you've already scripted some of those checks, it's extremely easy to onboard the scripts. If you haven't, still very good news, because our platform is extremely flexible and it scales well. We can check for thousands of new risk signatures and best practices. We can help you onboard your checks. And because it's agentless, it means that you'll have extremely good coverage. Every time a new platform is fired up, the tool will discover it, automatically apply the checks, no need to distribute scripts, no need to collect the outputs. So the answer is resonating, yes, that can easily be done.
Okay.
What else, Aran?
Two other questions here. One is a quick one, so I'll just bunch them together. One is whether the solution is on premises or in the cloud. And then a second question is related to the RTO and RPO violations that you spoke about. Can you talk a little bit more about how those are being tracked?
Sure. So for the consumption model, while I would love to say it's both, but in fact most of our customers today run it on-prem. The software itself, it's a pure software solution. So you fire up virtual appliances, you can fire one or more for any scale necessary, and it just runs there. We are working on a cloud-based offering. In fact, we do have a cloud environment that's currently in more of an experimental mode, just to demonstrate the capabilities that we can use. But definitely looking forward, our mission in life is to help match for each customer the best possible consumption model. So today it's on-prem. In the near future, you can choose between on-prem deployment and cloud services. Now, for the metrics, obviously a comprehensive answer may take some time, but I'll just try to draw the big picture. If there is interest, we can set up time offline to review the full details. But basically, Availability Guards correlates data points from multiple components. When it talks to servers and database servers and file servers, it understands where their storage objects lie. Let's say it's on a storage array. And from the storage array, it learns whether LUNs are replicated, yes or no, and how. Through how many ranks, clones, BCVs, snaps, true copies. And then it communicates with the storage management platforms to figure out what are the lags. And if you just piggyback copies like a BCV of an SRDF and then take a clone, we calculate the lag over each one of those to form a comprehensive view of your retention and exact RPOs. For RTOs, likewise, we actually figure out what are the design patterns. The tool automatically discover how resiliency is made up. So whether it's clustered, geo-clustered, is it VMware SRM, is it Zerto? So as it's tracking those structures, it assigns recovery time estimates on each one. So basically you can tell, whereas it's not accurate to the minute, just as our RPO measurement is, you can definitely figure out if specific applications are designed to recover in less than 10 minutes, in less than an hour, in less than 2 hours. And RTOs and RPO are not the only measures we allow you to document. These will also include how much capacity you'd like to have when a single site is out. Is it 100%? Is it 50%? Compute and memory. What are your software standards? Do you need things to be backed up? Do you need them to have security controls? So you can boil all of those into a very comprehensive service level definition that you can assign to services. And what the tool does is to automatically measure the actual versus requirements and throw all of that data both into graphs, the dashboards, and reports. So hopefully that gives you a flavor of what it looks like. Definitely a full answer requires a little bit more detail. I hope that covers, at least in part, the question.
Sure.
Do we have time for more?
No, I think we'll wrap it up here. We're running over time here, and those we do have still a few questions here, but as I said, we'll follow up offline with those that we didn't get to right here at this session. And obviously, there is much more to talk about the kind of things that we do and how enterprises can increase resiliency of their infrastructure, prevent their next outages. Obviously, we'd be happy to follow up on any questions and get into more details with each one of the people that attended here. So thank you all for taking the time. Hope you found it valuable, and we look forward to continue the conversation. Thank you and have a great day.
Thank you very much.